Hello everyone. Today we're going to be talking about parameter changes of quadratics. Remember, the graph of a quadratic is a parabola, so we're going to be seeing what happens to the parabola when we change different parts of the parent function. The quadratic parent function is y equals x squared, or f of x equals x squared. So what is going to happen to the graph of that function when we change either the value of a or the value of c? We're going to look at a few graphs and then we'll fill this in at the end of the video. So first of all, let's start by filling in a table of values for a couple of different quadratic functions. We're going to start with the parent function, f of x equals x squared. So to find the value of f of x or of y, remember y and f of x are the same thing. This is like saying y equals x squared. To find the value of y, we're going to square x, which means multiply it times itself. So negative 3 squared, that's negative 3 times negative 3 would give us positive 9. Negative 2 squared is positive 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. And notice how we have a minimum y value, and then the y values around that repeat themselves. So as we go equal distances away from the vertex on both sides, the y values are the same. That's how the parabola gets its U shape. Okay, let's look at a second quadratic function. G of x equals x squared plus 3. Or again, we could say y equals x squared plus 3. So this time we're taking the value that we already know for the parent function and we're going to add 3 to it. So 9 plus 3 would give us 12. 4 plus 3, 7. 1 plus 3, 4. 0 plus 3, 3. 1 plus 3, 4. 4 plus 3, 7. 9 plus 3, 12. And again, we have a minimum value, which is the vertex. And on either side of the vertex, the y values are the same, again giving the parabola that U shape. So let's graph these two functions and let's compare them. So we're going to graph the point 0, 0. We're going to graph the point 1, 1, and then go over here and we'll graph negative 1, 1. Then we'll graph 2, 4 and negative 2, 4. So 2, 4 and negative 2, 4. And 3, 9 and negative 3, 9. 3, 9, negative 3, 9. So there's that U shape. Now we're just going to sketch the graph of the parabola through those points. It doesn't have to be perfect. We just want to get that basic U shape. Now let's graph the points for the second function, g of x. So this time our vertex is at 0, 3. One, 4 and negative 1, 4 are the next points. Then we have 2, 7 and negative 2, 7. 2, 7, negative 2, 7. 3, 12 and negative 3, 12. 3, 12, negative 3, 12. And again, the parabola has that nice U shape. Okay, so what is the difference between these parabolas? Focus on the vertex. How has the vertex of the parabola changed? If you said that it shifted up, you are correct. So the general rule that we can write is that changing the value of c so c is the constant, shifts the vertex up or down along the axis of symmetry. Okay, in our example, we added 3 to the parent function. So we could see that the vertex shifted up 3 units along the y-axis. The y-axis in this parabola is the axis of symmetry. What do you think would have happened if we subtracted 3? Well, what would have happened is the vertex would have shifted down 3 units along the y-axis. Okay, let's look at another type of change. Let's look at changing the number in front of x squared. So if we look at our general form of the parabola, we're changing the a value. And let's see how the parabola changes. Okay, this time we're going to look at 3 different graphs. Okay, we already know the values of the parent function. We already figured that out. That was 9, 4, 1, 0, 1, 4, and 9. So how about h of x equals 3x squared? So we're going to take the value of the parent function and multiply it by 3. So 9 times 3, 27, 4 times 3, 12, 1 times 3, 3, 0 times 3, 0, 1 times 3, 3, 4 times 3, 12, 9 times 3, 27. So we can see that these y values are quickly getting larger. All right, let's do g of x equals 1/2 x squared. So we're going to take the value of the parent function and take half of it, or divide it by 2. So half of 9 would be 4.5. Half of 4 is 2. Half of 1 is 0.5. Half of 0 is still 0. Again, half of 1 is 0.5. Half of 4, 2. Half of 9, 4.5. And then we're just going to quickly graph those. And we want to notice what the difference in the functions is. So as you graph these, be looking for what the difference is. So 0, 0, 1, and negative 1, 1, 2, 4, negative 2, 4, 3, 9, and negative 3, 9. So there's f of x, our first parabola. Well, let's graph our second parabola. So its vertex is still 0, 0. Then we're going to go to 1, 3, and negative 1, 3. So 1, 3, and negative 1, 3. 2, 12, and negative 2, 12. So we can see, wow, these y values are getting big really fast. And we don't have room to graph any of the other y values, so we'll just leave it like this. So what did that do to that parabola, the fact that the y values were increasing so much more quickly? Well, it made it narrower, didn't it? Another way of saying that it's narrower is we can say that it's stretched vertically. It's kind of like pulling it upward and making it thinner. Now let's graph y equals 1/2 x squared and see what the difference is. So our vertex is still at 0, 0. and then we've got 1 and -1 at 0.5. And we've got 2 and -2 at 2. So these values aren't getting big near as quickly. We've got 3 and -3 at 4.5. So these values are not increasing near as quickly, so what does that do to the graph? It makes the graph wider, doesn't it? Another way of saying that it makes the graph wider is to say that it compresses the graph. You can kind of think of the graph as being squished down and spreading out. So what can we generalize about changing the value of A? We can say that changing the value of A, and that's the variable A, makes the parabola narrower. And another way of saying that it's narrower is to say a vertical stretch. It's stretched vertically. So it can make it narrower or wider. When it's wider, we call it a vertical compression. It's squished down. Okay, so when does it get narrower? It gets narrower when the number in front of the x squared is bigger than 1. It gets wider when the number in front of x squared is a fraction or something in between 0 and 1. All right, let's look at one more thing before we're done here. So what happens when we change the A value from positive to negative? And rather than using a table of values here, I'm going to use my calculator, and I'm going to graph these two on the calculator. And by the way, there's a link on my website that you can go to download this calculator onto your computer. It's not letting me click on it for some reason. Let me try it with my mouse instead. Seems to be stuck. Close it up and start again. Sorry about this, guys. All right, so I'm going to open up the calculator. So this is good to show you guys after you download it what you have to do to use it. You're going to click on File and New, choose TI-83 Plus, and then click on Debug and Go, and it'll bring up a copy of the calculator. So let's bring the calculator into the center of the screen. So we want to go to the y equals screen, and we want to look at the difference between 3x squared and negative 3x squared. So what happens if we change the a value from positive to negative? So let's press graph and look at the graphs. So here's y equals 3x squared. It's opening up, and y equals negative 3x squared is opening down. So a positive A value makes the graph open up, a negative A value makes the graph open down. Okay, so we're just going to do a quick sketch of those. Again, it doesn't have to be exact. We know that they were fairly narrow because the A value is greater than 1, but one was opening up and one was opening down. Okay, so what can we generalize here? We can say for positive A values, the parabola opens up, like the one on the top of the graph. And then we can say for negative A values, the parabola opens down. I'm going to go back real quick and look at those graphs on the calculator again. Lost it apparently. Well, let's just go ahead and look at them on my thing. I haven't drawn them extremely well. Let me draw them again. This is the vertex right here. It's a fairly narrow graph. Okay. What I'm wanting to show you here is that changing the value of A from positive to negative does not change the width of the graph. It does not stretch it, it does not compress it. It simply switches it from opening up to opening down. So the negative sign has nothing to do with how wide the graph is. What determines how wide the graph is? What determines how wide the graph is how close your A value is to 0, whether it's positive or negative. 3 is a lot further from 0 than 1/2 is. So that means that the graph of 3x squared is going to be a lot narrower than the graph of 1/2 x squared. Okay, let's just sum this all up and then we'll be done. So if A is greater than 0, our parabola opens up. If A is less than 0, then our parabola opens down. And then in general, changes in the A term make the parabola narrower. We also call that a stretch. Or wider. Remember, we call that a compression when it gets squished and spread out. And we can say that the further A is from 0, the narrower the parabola. Okay, and then the last thing is, how about changes in C? How do they affect the parabola? Well, remember, if C is greater than 0, the vertex shifts up. And if C is less than 0, or if we're subtracting something from the parent function, the vertex shifts down. And that sums it up for today.